Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on configuring layer 3 ether channels, LACP, and load balancing. Of course, LACP stands for Leak Aggregation Control Protocol, and that is a protocol that's within a channel group or an ether channel. All right, so let's go ahead and read our objective for this lab. It says EtherChannel can be used to provide high bandwidth, redundant links between switches. Link aggregation is performed by either Port Aggregation Protocol, PAGP, or Link Aggregation Control Protocol, LACP. PAGP is a Cisco proprietary protocol, and LACP is a standards-based protocol. In this lab, you will learn how to create a layer 3 ether channel by using LACP. You will also learn how to configure the load balancing method that will be used on an ether channel. All right, so this is our lab topology that we're working with. Of course, we have two switches, and the connection between these two switches, we have four fast Ethernet connections. And as we know, usually with spanning tree protocol, whatever our root bridge is, of course, our switch on the root bridge, all of the ports on that switch will be in the forwarding state and they will be in the designated mode, but the other switch will have only one link up, and that is to prevent spanning tree or layer 2 loops. That's what spanning tree protocol is built for, is to prevent layer 2 loops from happening within our network, because as we know, frames do not have a TTL field or time to live field like a IP packet does. Okay, so to prevent that from happening, or to prevent broadcast storms or layer 2 loops from happening, spanning tree is going to disable 3 of these links and only have one link up. Okay, and that'll be the root port on the other switch. Okay, so let's go ahead and read our commands for this lab right here. We have configure terminal, which enters global configuration mode from privileged exec mode. We have channel group number, mode auto. We have channel group number, mode desirable. We have channel group number, mode on. We have channel group number, mode active. And we have channel group mode passive. And this assigns an interface to an ether channel group. We have enable, which enters privileged exec mode. We have end, which ends in exits configuration mode. We have interface type number, which changes from global configuration mode to interface configuration mode. We have interface range, starting port, ending port, which configures a range of interfaces. We have IP address subnet mask, which assigns an IP address and subnet mask to an interface. We have IP routing, which enables layer 3 routing on a switch. We have ping IP address, which sends an ICMP echo request to the specified address. We have port channel load balance. We have source IP address, destination MAC address, source destination IP address, source destination MAC address, source IP or source MAC. And this configures the load balancing method used by the ether channel. We have show ether channel. Channel group number, detail, load balance, port channel, summary, or protocol. This displays ether channel information. We have show interface type number, which displays interface statistics. We have show running config, which displays the active configuration file. And we have switch port, which configures a switch interface to be a switch port. And we have no switch port, which configures a switch interface to be a routed port. Okay, so let's look at our IP address information. As we can see, we're going to have, of course, these physical interfaces are going to be bundled into a logical interface, and that will operate as one logical interface, and that will be the port channel. So our port channel is going to have an IP address on switch 1, and our port channel is also going to have an IP address on switch 2. And they're going to be using a /30 subnet mask, as we can see. All right, so we're going to keep our lab topology up here in the top left. We're going to be doing our task readings in the top right, and we're going to be doing our configurations down here at the bottom. Okay, let me scoot my camera over just a tad bit so you guys can see the CLI just a little bit better. I think that is going to work right there. Let me pull it over just a tad bit more, about right there. It looks good. All right, and we can still see the readings at the top right. All right, good. All right, for task number 1, it says configure layer 3. It says in this task, you will enable IP routing on switch 1 and switch 2 and configure the ports to be routed ports. So right here it says, on switch 1 and switch 2, enable IP routing. What are some reasons you might perform this action on a layer 3 switch? All right, so first, let's pull up switch 2, and we already on switch 1 right here. So let's do an enable, and let's do a configure terminal, and let's do IP routing to enable layer 3 capabilities on this switch. Let's do the same thing over here on switch 2. Enable, configure terminal, and let's do IP routing. All right. So to answer the question is, what would be a reason that you will perform this action on a layer 3 switch? Well, of course, as we know, switches are layer 2 devices, but there are certain switches that are layer 3 capable. So in this case, we're not changing. The switches will still be able to switch information at the layer 2 level, but they can also determine for themselves how information is supposed to be sent at the layer 3 layer as well, which is the IP layer. Okay, so let's see what Boson is going to say. It says, although you are not configuring routing or routing protocols in this lab, you must enable IP routing on a layer 3 switch in order to configure a layer 3 network, including IP addressing on a switch. Issuing the IP routing command on a Cisco iOS device that supports it enables the device to behave as a router. Therefore, issuing the IP routing command on switch 1 and switch 2 enables them to forward packets between broadcast domains without connecting to an additional device. And yes, if we want to configure IP address information on a switch, we do have to enable IP routing, okay? So right here for number 2, it says, right here on number 2, it says, on switch 1 and switch 2, configure the interfaces from fast Ethernet 01 through 04 to be routed ports. What features do routed ports support on a layer 3 switch that non-routed ports do not? All right, so let's go to switch 1 first. And let's go to interface range, fast Ethernet 01 through 4. And let's do no switch port. All right, let's do the same thing over here on switch 2. Let's go to interface range, fast Ethernet 01 through 4. Let's do no switch port. And hit enter. All right. So now we have configured routed ports on all of those ports. And let's see what Boson is going to say. It says, unlike switch ports, routed ports can access the header information that resides beyond the data link layer of a packet. For example, routed ports can examine the IP address information that is contained in the network layer header. All right. So it gives us the ability to look into IP information on a port. All right, so that is good information to know. So let's go ahead and move on to task number 2. It says configure layer 3 EtherChannel by using LACP. It says in this task you will create a layer 3 EtherChannel by using LACP. So on number one, it says on switch 1, issue the command to configure the interfaces from fast Ethernet 01 through 04 to be members of port channel 1 by using the passive mode. What is the purpose of using LACP with EtherChannel? Well, using LACP with EtherChannel is a standards-based protocol, so you can use it between different vendors. And of course, it gives us more throughput, and it also gives us redundant links within a port channel. So let's go ahead and do that. Let's do channel group 1 mode passive. Hit enter. And as we can see, it says our port channel interface was created. All right. Now it says on switch 2, issue the command to configure the interfaces from fast Ethernet 01 through 4 to be members of port channel 1 by using the active mode. How is LACP active mode different from passive mode? Well, active mode is going to actively try to negotiate the port channel on the other side, while passive mode is not. Passive mode is more reserved. It's going to form a port channel if the other side is in active mode, But if both sides are in passive mode and no side is trying to actively negotiate the port channel will not come up. All right. So let's do a channel group 1 mode active. And since this side, oops, I didn't mean to do that. And since this side is going to be active, the port channel will come up. All right. So number 3, and as we can see from the output as well, it says the line protocol for port channel 1 has changed to up. All right. So it says on switch 1, issue the command to display interface information for port channel 1 and verify that port channel 1 interface exists. And what state is the interface and why? So let's go to switch 1. I'm going to switch 1 now. And let's do a do show IP interface brief. And as we can see down here, our port channel 1 interface, our status is in the up state and our protocol is also in the up state. All right. So that looks good. Number 4, it says how much bandwidth can be used by this interface. Well, if we look at our topology, we see that we have 4 fast Ethernet interfaces, and they're all combined with it to one logical interface. As we know, fast Ethernet interfaces gives us 100 meg. So we should have 400 meg or 400 kilobits per second. But let's check it out and see. Let's do a do show port channel do show interface, excuse me, port channel 1. And yes, as we can see, our bandwidth is 400 kilobits per second or 400 meg. All right. So on number 5, it says on switch 1, issue the command to display summary information about the ether channel and what state is the port channel interface and why. All right. So if we do a do show ether channel summary, we can see that our port channel 1 has the RU output. And of course, R just means that we're on layer 3, as we can see by the output. And we can also see the capital U means that we're in use right here. We can look at our protocol and say that we're using LACP. And all of our ports have the P beside them. And the P means that each port is bundled within the ether channel. And that is what we want to see. All right. So now it says on switch 1, issue the necessary command to configure the port channel 1 interface with an IP address of 192.168.1.1 and a subnet mask of a /30. What configuration change did you previously make on switch 1 that enables you to assign the IP address information? Well, the first thing that we did was we enabled IP routing on the switch. So that allows us to configure an IP address. And also we made the all of the switch ports, all of the regular switch ports to be routed ports. All right. So that's what is going to allow us to assign the IP address information. So if I do an exit and I'm going to interface port channel number 1, and I give an IP address of 192.168.1.1. And let's do that /30 mask, which would be 255.255.255.252. Oops, if I can type 252. Hit enter. Let's do a no shut to make sure it's up. All right. And let's do a do show IP interface brief just to make sure that it's up, and it is. We can see our IP address that we just configured. All right. On number 7, it says on switch 2, issue the necessary commands to configure the port channel 1 interface with an IP address of 192.168.1.2 and a subnet mask of a /30. So let's go to switch 2 and basically give an identical configuration, but just change the end of the IP address information. So let's do an exit. Let's go into interface port channel number 1. And let's do an IP address of 192.168.1.2. 255.255.255.252. There. Let's do a no shut. Let's do a do show IP interface brief. All right, and we can see that IP address information is here within switch 2 as well. So number 8, it says from switch 1, ping port channel 1 interface of switch 2, which has an IP address of 192.168.1.2. Is the ping successful? So let's go to switch 1. Let's do a do ping 192.168.1.2. And we are able to ping the port channel 1 interface on switch 2. All right. So step number 3, it says configure EtherChannel load balancing. It says in this lab, you will configure load balancing on an EtherChannel. So number 1 says, on switch 1 and switch 2, issue the necessary commands to verify the current EtherChannel load balancing method on each switch. What load balancing method is being used? So let's do an end on switch 1. Let's do a show EtherChannel load balance. And as we can see, the EtherChannel that we're using, the EtherChannel load balancing method that we're using is just the source MAC address. All right. And let's do the same thing over here on switch 2. Let's give an end. Let's do a show EtherChannel load balance. All right, hit enter. And also switch 2 is only using the source MAC address. All right. So it says on switch 2, on switch 1 and switch 2, configure the load balancing method so that EtherChannel uses source and destination addresses to load balance traffic. All right. So, oops, I accidentally scrolled down. All right, let's go to switch 1. Let's give a configure terminal. And let's do a port channel load balance. And we want to do a, what does it want? It wants source and destination IP. So let's do a source, destination IP. All right. Let's do the same thing over here on switch 2. Let's give a configure terminal. Let's do port channel load balance, source, destination IP. All right. Now on number 3, it says on switch 1 and switch 2, issue the command to verify the EtherChannel load balancing method has been changed. So let's go to switch 1. Let's give it end. Let's do a show EtherChannel load balance. All right, and now we can see that we are load balancing using the source destination IP. Let's confirm that on switch 2 as well. Let's do an end. Let's do a show EtherChannel load balance. And we can see that we're also using a source and destination IP on switch 2 as well. So that looks to be the end of this lab. So let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.